The periodic table is an arrangement of the chemical elements by atomic number. These elements are grouped together in such a way that they share similar properties. For instance, we have as the first element hydrogen, and in the upper left-hand corner of each element we have their atomic number, which is the number of protons for that element. So for the second one we have helium, for number 3 we have lithium, beryllium for number 4, and so on. The first concept that you should know about periodic tables is that of groups. So groups in the periodic table are the vertical columns. So group 1 is hydrogen through francium, group 2 beryllium through radium, then we have group 3, 4, 5, 6, 7, all the way to group 18, which is from helium through oganesson. The second concept that you should know is that of periods. Periods in the periodic table are the horizontal rows. So period 1 is hydrogen and helium, period 2 lithium through neon, period 3 sodium through argon, and so on, all the way through period 7. Let's talk about the different groups in the periodic table. The elements in group 1 are called the alkali metals, and they are soft and lustrous metals that melt at low temperatures. They all produce hydrogen when they come into contact with water, and they are quite reactive, so they are not found in their pure form naturally. As an example, we have lithium, which is used in lithium-ion batteries for your cell phones, your computers, and in electric cars. Next, we have the members of group 2. These are called the Alkaline Earth Metals, and their properties are similar to the ones in the alkaline metals, but their reactions are less vigorous. One example is beryllium, which is a light metal and it is used in the production of radiation windows because it has little absorption to X-rays. The elements between groups 3 through 12 are called the transition metals, and as their name indicates, they are transitional in character between the more vigorously reactive metals from groups 1 and 2 and the less vigorously reactive metals from groups 13, 14, 15, and 16. Next, we have the elements of group 17, which are known as halogens. Halogens occur as diatomic molecules, that is, molecules consisting of 2 atoms. They are quite reactive and they tend to form salts with elements of group 1, and they vary in color a lot. One example is chlorine, which is used as the main component of bleach. Bleach has a formula of sodium, chlorine, and oxygen, and it is also used to disinfect water. Then we have the members of group 18, which are known as noble gases. They are so called because they combine with very few elements. All of these elements are colorless and odorless. One example is neon, which has many applications such as neon lights, fog lights, lasers, and advertising signs. All of the chemical elements can be classified as metals, metalloids, and non-metals. As you can see here, all the elements in blue are metals. The ones in green are metalloids, and the ones in brown are non-metals. Metals share similar physical properties, which include the efficient conduction of heat and electricity. They are malleable, which means that they can be hammered into thin sheets, and they are ductile, which means that they can be drawn out into wires. One example is copper, element 29, which conducts efficiently electricity and heat, and it is commonly used in electrical equipment such as wiring and motors. And it can be used also in plumbing and in cooking utensils. Next, we have non-metals. Non-metals are, for the most part, poor conductors of electricity and heat, and they are neither malleable nor ductile. Chemically, they tend to gain electrons to form anions with reactions with metals. For example, we have sulfur, which is a brittle yellow solid that poorly conducts electricity, and it can be used to make sulfuric acid, which is used to make fertilizers. Next we have metalloids, which in appearance they can look like a metal, but chemically they can behave like a metal or non-metal depending on conditions. For example, we have silicon, which is a semiconductor, meaning that it does conduct electricity, but as temperature gets higher, it becomes a better conductor of electricity, unlike metals, which become worse conductors of electricity as temperatures go high. Silicon is a crucial component in microelectronics and computer chips, and when they oxidize, they become silica or silicon dioxide, which is a common component of sand. Something to notice in the periodic table is that in the transition metals in period 6 and 7 there is two breaks, 57 through 71 and 89 through 103. So they are down here. So the first row is called the Lanthanides, and the second row are called the Actinides. So Lanthanides are also known as rare earth metals, but this name is misleading because many of them are actually quite abundant. About 52% of these rare earths are in China and 13% are in the USA. They are silverly white and relatively soft metals with high melting points and high boiling points, and they are very reactive, especially with water. And many of these fluoresce under ultraviolet light. As an example, we have lanthanum, the first element here, which about 10 kilograms are used in nickel metal hydride batteries for hybrid cars. Then below the lanthanides we have the actinides, which are radioactive and unstable elements. They tarnish in air and they are heavy and dense metals. They can combine with most nonmetals, and the elements up to plutonium can be found naturally, but the ones after plutonium are not naturally found, but they are made in the laboratory. Examples of actinides include plutonium and uranium, which have been used in the nuclear industry to create energy in powerful bombs and generate electrical power. Finally, let me add a few comments about this break in the periodic table. So this is due to two reasons. One is due to aesthetics, because if we add the lanthanides and actinides here, the periodic table would look too wide. And the second reason is because this makes it easier to group the elements in terms of similar atomic structure properties. So this is something that we will discuss later in these lectures, but as a brief comment, let me mention that groups 1 and 2, including helium from group 18, belong to the S block. Groups 3 through 12 belong to the D block. Groups 13 through 18, excluding helium, belong to the P block. And then the lanthanides and actinides belong to the F block. So as we can see here, is something like this: the S block, group 1 and 2 including helium, the D block, all of these, the P block over here, and then the F block down here.